So first and foremost, we did a little technical check before the talk during the break, and it turns out like there will be a lot of code examples and they will be like really tiny. So for the people who are really interested, maybe you can somehow come closer or like move the chairs or something. Or worst case, then like I will share the link to the slides so you can see it properly after. But hey, we will do the best of it. Okay, so let's talk about the next level dynamic Angular UIs unlocked. So what are the like dynamic UIs? What should we imagine, right? So maybe we have some kind of like dynamic form builders, right? So like some generic, you define like you have a configuration for your fields and you render them based on that configuration, or you have some kind of dashboards, right, where the user can choose like different widgets and arrange them how they want. Or nowadays, even like with the chat interfaces, maybe we are rendering some different components there based on some conditions. Or like CMS systems, rich documents, you want to instantiate some components there. So there are quite some many things, and today we will focus on like this kind of like a use case where we want to create some kind of dynamic dashboards like this. So this is like one of the applications I've created some years ago called Omniboard, which allows you to analyze large enterprise environments and their code bases and repos, and you can see you can create this kind of dashboards. You have different dashboard items, as you can see. You can arrange them differently or even different types, right? So this is a pretty common use case where building systems. And today we are going to have a kind of like a historical overview where we say like which APIs are available from which Angular version. And there will be like three main approaches how we can try to solve something like this. As already Julian told us, right? We can have like some kind of beautiful, huge switch statement, ng component outlet, or a view container ref. And we will see all of them in action. We will kind of refactor from one solution to another, and we will also discuss the trade-offs of each specific solution. Quick introduction, as I already kind of got, but hey, Tomas, Trajan, Google developer expert for Angular and web technologies, and I like to say that I build, teach, write, and speak with and about Angular. So build AngularExperts.io, we support companies worldwide, reviews, architecture, whatever they need. Teach, workshops, Angular and GRX. Write, we have an AngularExperts.io/blog, even though we are less active now because, with the AI, like writing kind of lost its charm, but hey, it's true, right? Like it's the video where it's at, right? And speak at various conferences and meetups around the world. Very happy to be here again with you. Thanks, Michael, for making this possible. All right. So let's just jump straight into it. First thing I would like to address, and especially for this dashboard use case, it is very good to think about separating the main concerns of like how the things are layouted and then how like the actual specific dashboard item types are implemented. So what would that mean? We have some kind of dashboard, we have some columns, we have some rows, and then of course those items can take different shapes, different sizes, and we want to be able to specify that. But then of course those individual items have then completely different implementation because they visualize the data which we feed into them in different ways, right? So we want to decouple that, and we will see that we will have like some generic dashboard item which takes care of the layouting and also of dynamic rendering of all those other item types which then process the data and provide us with the visualization. Okay, so and the first approach is just the standard Angular template. This is something which was possible since forever, right? We had ng, we had the ng switch, and first we take care of the layout. So, and I hope that you can see at least a little bit, but we have a dashboard item, right? And now this dashboard item will be, rendered in, let's say, some kind of dashboard container. We will iterate on all those items, and we will also receive the layout config. And nowadays with signals, maybe we calculate some kind of grid area, and we will bind it to the host, and the layouting is solved. Of course, it's like a simplified version, but this can be something like this. So, and now onto the dynamic item, right? So very trivial. We get like, again, from the parent, from the dashboard container, which probably got it from the database, some kind of config. And then we provide a beautiful switch statement, right? So we have the item type A, render item type A, item type B, render item type B, nothing crazy. So, and then of course, probably we need to feed some data into it. So we pass in the data, and maybe have some different kind of data, so that like those that can be used to merge it to provide some kind of more advanced visualization or provide, more information for the users who are seeing those dashboard items, and we just bind it as well. This is what we have been doing in Angular since forever, right? And then maybe we have like some kind of export functionality, so we can, export the data and the user can print it or copy it into the clipboard or export as a JSON. So we bind an outlet, right? Sorry, like the output, and call our handler. So, and this is actually very realistic approach if you have like a one-off dynamic dashboard use case and like you don't have to do it anywhere else. Everybody can understand this. It's like the most basic Angular there is. So it's, very simple and it gets the job done. Now, until Angular 16, there would be like a huge downside of this approach. Let's say we had like 25 different dashboard items and some of them are like pretty complex and maybe load some chart library or something like this. This would, of course, balloon our bundle size, right? But since Angular 16, we can just wrap every single one of them with defer, and that way we get also the lazy loading for free out of the box. So what does that mean? If I come to like a specific dashboard for, like some global one or for some user, and the dashboard only uses 2 items, then all those 18 items will be skipped and not loaded. Problem solved, right? Perfect. So, this is like a valid approach, which if you have like a one-off use case, you can do it. You can use if or switch statement. This was possible since forever. It was a bit too heavy until Angular 16, but now even this is solved, right? And you can even optimize further. If you know that dashboard has too many items, you can add like differ on viewport, so you postpone it even more. So it works very well. It's verbose. We have to repeat the inputs, outputs, defer, and other stuff for every single of those items, but it's very flexible. Let's say you didn't really specify strong convention for how those items should be implemented. Maybe they don't have a consistent namings for the inputs and the outputs. This is no problem with the template approach because you can just pass in to any kind of input or output. It's like to alias it. It's not a problem. And it's of course also possible to use the directives and content projection via in the template, right? But it's hard to use. We implemented in that one specific case as a dashboard item. Now let's say in other part of our application, we also have some kind of generic UI requirements. It will not be transferable. We would probably have another such a switch statement. And if you have it in many, many places, then probably there is a time to make it better. And as a tip, always make sure to separate the layouting from the actual types. So that means like that those individual dashboard items or any other generic components should not lay out themselves. It should be layouted in some kind of container. Perfect. So and then in practice, it would be more like this, right? There will be like much more inputs, much more outputs, and it will be, not just 2 items, but maybe like 20 items, and then it starts to get a little bit problematic. Okay, so now the way to improve this could be using component outlet. Who here ever used ng component outlet? Ooh, wow, quite some. Perfect. Then I want to hear about your dynamic use cases actually. Okay, so now again we have this dashboard item. We are receiving all this data from the parent, right? We are already solving the layout, and let's use the dashboard, so component outlet. So we import the ng component outlet, use it on our ng container, and basically we want to retrieve the specific component type, but now it will not be in a template, but it will be in some kind of registry, like some kind of data structure in another file, right? And then based on the dashboard item type, which we retrieve from the parent, we just get the component from that registry and store it in a type. And then we pass it into the outlet. Perfect. So now what about the inputs and the outputs? The inputs got actually pretty cool. I think it's from the version 16. We will see that later. We can do something like this, create a computed, and then just pass it into the ng component outlet, problem solved. But now with the outputs a bit more tricky, because as of now, there is no nice declarative way to bind to the outputs when using the ng component outlet. So we have to do some kind of code around it. So first we have to get a reference to the outlet itself, and then create some state property where we are going to store the subscription. And then we can use something like an after render effect. And in there, of course, if we had a previous subscription, we unsubscribe because maybe the type has changed during the runtime. So we need to like resubscribe again if the type has changed. And then we check if we have our outlet already. And we also check for the type. So if the type changes, then we kind of rerun this whole thing and reset up the subscription to the outputs. And after that, we get the outlet component instance, get the output, subscribe, and call our handler. So it works, it's a bit verbose, it's a bit imperative, but it gets the job done. So now, what about the synchronous versus asynchronous registries? So we said like we have just like some kind of data structure in some file where we will have like, you know, the component type and the component class. But again, we will have a problem with the bundle size because in such a case, we would import all these 20 components eagerly, like with the standard TypeScript import. So what we can do is to rework this into a dynamic imports, and then again, we achieve the lazy loading with just this small change. So then for every type, we store an arrow function, which will then lazy load that component when it's executed, right? So then let's switch that implementation again. Previously, we just did a computed and got the component class from the registry synchronously. Now we switch it. The type will be just a signal of type or null. And we will create another effect, a synchronous one. And then instead of just getting directly, we will await it and call that import method. Perfect. We are lazy loading again. And of course, we have to set the type so that it gets set to the ng component outlet. Perfect. So as we can see, this is much shorter compared to like that huge switch statement where we had to repeat every single item. It's pretty generic. So we reduced the verbosity. The template is basically simple. And I was actually surprised that this was possible from Angular 4. Like I haven't used it back then. We have a declarative inputs with this inputs property, which we can pass into the directives in Angular 16.2. But the outputs are imperative. And from what I understand, that reference to the component instance which we got there with the view child is only available since 19.1. So from my understanding is that there was no way to listen to the outputs all the way until 19.1. And this is also kind of interesting that we will see like 3 different approaches to kind of solve the same concern and how they evolved like in their own pace, and like they try to kind of achieve like the feature parity, but it's still not there. But I think in the end we will see that there is a clear winner. Okay, and of course it supports the content projection, but not really the directives. There is no way to use the directives on the ng component outlet as of now, as far as I am aware. And another big problem is whenever we change something which we are passing into the directive, so like if we pass in the type, of course, we kind of want to tear down the previous component and create a new one because it's a different kind of component. But if we pass in like a different projected content, then maybe that doesn't really sound like something which we would want to tear down the component, but it actually happens. So this is not that cool. And of course, as a tip, we should always use the async registry. Okay, so is there a better way? Well, as you can guess, of course there is, and especially nowadays, we can use view containers or specifically view container ref. And first we will show like the pre-Angular 20 version, just to illustrate like how much better it got. So again, we have our dashboard item, which receives the data. We don't really show the layout anymore because there is no space and it's pretty tiny. And now let's start building this. So first we create a after render effect, which will be asynchronous, and we load again like the lazy load the component, right, based on the component type. And then we add the template with the ng template and a host marker and use a view child to get that view container ref, which will allow us to dynamically create component based on the type. And we also store a reference so we can destroy it when it changes to clean up. Okay, so let's create that component. View container ref create component based on type. Perfect. And now starts again like this imperative way of doing things because the new way will be only available from Angular 20. So first, let's have a reference to the subscription because we again want to subscribe to the output imperatively. So we get the instance, we have the output, we subscribe, we call our handler. Perfect. And now comes a little bit not so nice thing. So we create like a helper method, which we will call like sync inputs. And inside of there, we will use this, we get again the reference to the component, and we have available this method called set input. And we can say like the input name and what we want to set into it. So one is the signal for the projects, one is the signal for the dashboard items, and like the data property. And here is where the problems start. So basically we want to, or actually need to set the inputs also during the component creation because those inputs were required, right? This is often the case that if we create some component, it has input.required. So we need to do it here, but we have to wrap it with untracked because we do not want to trigger that effect, which should only rerun when the component type has changed and not when the input has changed, right? So we wrap it with untracked, and then if those signals change during the runtime and we want to sync those inputs, they will get dirty, but the effect will not get dirty because we've wrapped it with the untracked. But then later, during the runtime, we just want to sync the inputs, so we have a normal effect without untracked, so whenever any of those signal changes, it will trigger this effect again, and it will sync those inputs inside of that dynamic component. And then the cleanup, of course, we want to unsubscribe and destroy, and we want to do it whenever we create a new component, when the type has changed, or of course, when the whole dashboard item was destroyed. So it's more verbose and like kind of worse than the ng-component outlet. It has imperative inputs and outputs. The set input is available since 14.1. Before that, we would have to do instance prop equals value and run the change detection. But what is better is that we have full control over the lifecycle compared to the ng-component outlet, where basically we pass something to the directive, we lost the control, it will just destroy and recreate. Right. So and now on to the best way. So with the modern APIs for the view container ref. So again, we have the same setup, right? We have the dashboard item, we already have the template, we already get the view container ref from that template with the view child, we already are storing the reference to the component, we are getting and instantiating like the, well, basically asynchronously importing the component, and we are already creating component with the view container ref. So now there will be the difference. Instead of doing this imperatively, we can pass in new config object, and that config object will have a bindings array. And inside of that array, we can now use this new declarative, very straightforward, easy to understand API. Let's add an input binding, right, for the data. And here we are passing a arrow function because it's not just the signal, but it's the sub property of the signal. And the cool thing about this is, even though it happens inside of that effect, it's not really a problem because we are not executing this signal during the definition time or like during the runtime of the effect. We are just passing a arrow function inside that binding. So it will run at a different time, and therefore it will not be connected behind the scenes in a signal graph. So when the signal changes, it will not mark this effect as dirty. So it will not tear down and recreate the component. So this is great. And of course, we can just pass in the reference to the signal itself without calling it. So again, it's the same thing. We are not calling the signal during that effect time. So then even if the value of that project signal changes, it will not trigger this effect and the component lives. And finally, we also get a declarative bindings for our outputs. So we can provide the output name, we can pass in the handler, which calls our handler. Perfect. But it gets even better. We can also do the two-way bindings, and we can specify the directives. So you can just list the directives as they are, or you can make like the long form where there is the directive type, and again we can pass in bindings. So for example, we have some kind of drag and drop. So and then output binding, when dropped, please handle dropped. So we have the same API, fully declarative, no problem. And this is pretty amazing if you ask me. Cool. So much less verbose, fully declarative API for inputs, outputs, two-way bindings, declarative API for directives. And it also supports content projection, even though I didn't show it ever because there is just no space. You can always pass in projected nodes, so you can get a hold of your template or just create some nodes and pass them in again, like declaratively. And there is no signal graph issue, right? So no need to use untracked or anything like this, which is great as well. Perfect. So basically we've seen like three different ways, right? You can do like the switch, you can do the component outlet, which nowadays seems to like not be the way to go because it only allows for the imperative outputs. Then we've seen the view container ref old style and with the modern APIs, which is definitely better. And now we can explore a little bit like how it could be taken even step further. with like abstracting this whole machinery away and make it more usable. So, and this will be like a custom abstraction, so it's more just like to illustrate how it can be done. I'm not saying that you should do it like this and very simplified. I think it really depends on what your specific use case is, what your specific constraints are, just to like give you an idea. And when you would want this, for sure not if you have like just one place where you use it, then you know it's not a problem. But if you have some system which heavily needs to do a lot of dynamic UIs in many places, then it might be worthwhile to extract it as a generic solution. So in this solution we'll have three main parts. One will be like a registry, which we already have, but we will extend it with some additional stuff. Then the second part will be a generic dynamic UI host directive, which will take care of that heavy lifting on instantiating those dynamic components, synchronizing the inputs and outputs and all this kind of stuff. And then the third part is what we already have, is this consumer component, which actually wants to instantiate those dynamic components. So let's have a quick look how this could look like. So first the registry. So this is what we had previously, right? We had the registry where we had just like for this component, this is how we load it. It was just a key holding an arrow function with the import statement. But now, instead of that, it will be a configuration object. So it was just like direct arrow function, right? Now it's a configuration object, which is an import or let's say load. And we can add some other stuff. So here we will just have like a very simple abstraction, which will just have the string names of the properties which we want to bind to that specific component. Of course, in practice, you will do it type safe. Maybe we'll have some enums, maybe we'll have some convention, maybe we'll have some library which has like the interface which all the other libraries have to implement, right? We will do it much cleaner. This is just to illustrate the mechanism how this can work, right? So each component will be described. So it expects to get these inputs and those outputs, and they don't have to be the same, right? And of course, it can be also for the two-way bindings. It can be for the directives. And of course, this could also then be extracted into a library, right? So we are getting into this kind of slowly like a plugin system where you have like the dashboard plugin, you have like sales plugin, you have order plugin, whatever you want, and they all can deliver those configs and the dynamic components. Perfect. So now the main meat of it, this dynamic host directive. So we will basically take most of the implementation which we previously had in a component and move it into a directive. So let's create this directive dynamic host. We just get a view container ref for the directive itself. We do not need the template, which is the ref of the directive. And again, we have this after render effect, and we have some cleanups, which is like the boilerplate, right? And now we will have the first input which will receive that configuration. Again, you will have like some well-known interface which all those providers need to implement for the configuration, right? And based on that configuration, we want to retrieve the configuration for a specific dynamic component, but for which one, we don't know, because the parent will tell us, right? So we have another input, and now we are just setting the string. It's like a type A or type B, but of course in the practice it will make it nicer. And based on that, we retrieve the actual configuration. Perfect. So then we can, again, lazy load that component, right? Because the configuration contains it in the import property. And then we can dynamically create that component. So now, and now we want to specify the bindings. So how could we do something like that? So we said like that the configuration contains like this list of properties, right? So I expect the data and I expect the projects. So that means that the parent has to send inside of that directive the providers, like some kind of data sources, which also contain, let's say, signals in the data and in the projects, right? So then we say like we expect the input, which has like a record of string and a signal, like that's our convention, that we pass in the data sources, that under the property there will be a signal. And then we can go to the config, iterate all the properties which we expect as inputs, and try to look into those data sources if there was such an input. And of course, if there wasn't, we fail fast, so that the developer knows that, okay, I need to pass in another data source. And if there was, we just create the input binding. Perfect. And then we can just spread all these input bindings into the bindings array. And the same for like the outputs or the handlers. Again, based on that like convention and the interface, the consumer component not just only have to provide the data sources, but also all the handlers. So some kind of like a record with all the handlers, right? So we pass in the handlers, and we will do the same for the output bindings. We'll go through all the properties and create the output bindings, spread it out. Same for the two-way bindings, same for the directives, right? So again, very simple. It would work in practice. It would be a little bit fragile, right? You will just get like error if you didn't match it properly, but it can be for sure done more robust. Perfect. So now, what about the dashboard item itself? How does it get simpler because we now have this directive, right? So previously we are doing all this view container ref here, and that means also if we had, dashboard items, and then we will have some kind of sales whatever or a CMS whatever, we will have to re-implement it over and over. But now, because we have the directive, we can use the directive on all those places, right? As long as we follow some convention. So let's add the ng container, import our new directive, and use it on that ng container. And now we know we have to provide a couple of inputs, right? So first we import this registry from somewhere, store it on the component so that we can pass it into the directive. Then we also already know this, we knew since forever, which is the current type which we want to render as a dashboard item. And then we have to prepare like these data sources or input sources, right? So let's do the data, which is from the dashboard item. And this should have been projects, which is the projects. Perfect. Now we can pass it in. And same for the handlers. And we can pass it in. So now, basically, we extracted that whole machinery in a reusable directive. So then we only deal with the registries, which are configuration driven, basically like some objects which describe all these components, which again can come from some library or somewhere else. And then the directive does the heavy lifting. And then the consumer became trivial, which is specify the data sources, specify the handlers, and it just starts to work, right? So that way it's much easier to reuse in multiple places. All right. So we have this reusable generic directive, works with multiple configs at multiple locations. Consumer became trivial. It's a custom abstraction, right? So whenever we are getting into that land of building like our own framework in a framework, it really depends if it's something which we can justify, if we have enough use cases for it. If not, maybe it's easier to go with like a simpler solution which everybody will know, because everybody kind of knows the Angular, but if somebody joins your project and they have to learn 5 different custom abstractions, that's additional friction and learning curve before they can get effective. But again, it's a trade-off. Maybe it is worth it in your specific circumstance. So, and it also supports plugin style composition when you extract all of this into the libraries, and it could be even extended more to support like some kind of decoupled plugin widgets. But the thing is, in Angular, if you don't use module federation, you need to know about all those components, even though they are imported asynchronously at the build time of the application, right? You cannot just like point to like the HTTP my.org/button. That only works with federation. But if you want, you can extend it with the federation, and then you can really load anything from anywhere, build an app store, widget store. It is possible. Perfect. So the key takeaways, for sure, always think about separating the layout concern from the dynamic components themselves. There are multiple ways to solve this. We have the template, we have the ng outlet, and we have the view component ref. I would say nowadays, with the current state of API, if you have a one-off case, then use a switch. It's, everybody will know what it is. Like, it's a very basic API. Everybody can easily understand, change or fix it, right? You can always lazy load with the defer. And if you have use case where you need to do it in many places with many different configurations coming from many places, then you might be interested in creating some kind of convention and reusable abstraction. You can still lazy load with import, and also like for the plugin system. Right. So there are 2 links if you want to check this out for the presentation itself, and there is like a very rough research repo on the GitHub as well, where I was trying all these things like live. So feel free to check that as well. And with that being said, I hope you enjoyed and enjoy the rest of the conference. Thank you very much.